Today we are going to look into overview of the global semiconductor industry in 2025. The market is projected to reach 701 billion US dollar this year, reflecting an 11% growth compared to 2024. The strongest growth segments are logic chips growing by 29% and memory chips growing by 17%. This growth is mainly fueled by advancement in artificial intelligence, 5G and forthcoming 6G network and expanding data center infrastructure. The Americans and Asia Pacific regions are leading this market expansion while Europe experiences moderate growth and Japan sees a slight decline. Globally, more than $500 billion in private investment are underway to boost production and R&D capacities. India semiconductor industry status 2025. Turning to India, the semiconductor market was valued at 38 billion US dollars in 2023 and is expected to reach between 45 to 50 billion US dollar by end of 2025. The Indian government has approved 10 semiconductor projects with investment of approximately 18 billion US dollars targeting design, fabrication and packaging capabilities. India aimed to launch domestic chip production by the end of 2025, focusing on made in India chips and supporting the rollout of 6G technology. Additionally, the government has committed around 7 billion US dollar in incentive under the India Semiconductor Mission or ISM. Now, the demand for semiconductor is driven by several key sectors including artificial intelligence accelerators, autonomous vehicles, 5G, 6G network, data center and consumer electronics. AI-enabled devices, generative AI technologies push the industry towards creating highly specialized chips, moving away from generic designs. There is also a surge in memory demand, especially for high bandwidth memory version 3 and 4 used in high performance AI and compute servers. While automotive and industrial segments are recovering, they face cost related challenges in this competitive market. India's semiconductor demand is increasing due to growth in electronics manufacturing, telecom network, and the electrification of the automotive sector. A core goal is to localize the supply chain covering wafer fabrication, packaging, and sourcing of raw material including critical mineral to reduce dependence on imports. Although India has a strong talent pool for electronics, there is a shortage of skilled manufacturing workforce, especially for semiconductor fabs. Focus area for future including emerging technologies like quantum computing chips, AI processors, and clean energy semiconductors. The semiconductor industry faces a global shortage of skilled talent required for manufacturing, research and development and advanced chip design. In India, scaling up fabs and the broader ecosystem require highly trained operators and skilled personnel, making training program essential. The country also faces brain drain and stiff competition for talent from established hubs such as Taiwan, South Korea, and the USA. A strengthening collaboration between industry and academia is needed to build a sustainable type pipeline of semiconductor engineers for the future. Machine on the technology and infrastructure front, high capital and operating cost for fabs are a major challenge, especially in US and Europe. Though India's cost, while somewhat lower, remains significant. The supply chain for raw material like silicon wafers, specialty gases and rare earth element is complex and vulnerable. Adapting to advanced semiconductor nodes demand continual investment in R&D focus on material, packaging and design innovation. Developing a local ecosystem of equipment suppliers and material manufacturing is a critical step for India's semiconductor ambition. Manufacturing semiconductor globally require over 1 trillion US dollar in investment by 2030. India's government has pledged over $7 billion, while private sector's investment in manufacturing and assembly are increasing steadily. However, semiconductor fabs have high upfront capital cost and long gestation period, necessitating sustained capital flow and supportive policies. Balancing the need for cost competitiveness alongside quality and innovation is vital to make semiconductor manufacturing viable in India. Recent development in the semiconductor industry include massive investment worldwide in AI-focused chips, edge computing solution, and advanced packaging technologies such as heterogeneous integration. In the US and EU, onshoring efforts are supported by subsidies and policy measures like CHIPS Act and Inflation Reduction Act. In India, ISM 2.0 extends support across the entire semiconductor value chain. New fabs are upcoming in Indian states such as Odisha, Punjab, and Andhra Pradesh with active international participation. The Semicon India 2025 event showcased accelerating industry collaboration and launched several new technologies. To build a robust semiconductor ecosystem, strengthening industry academia partnership is crucial to nurture talent and drive innovation. Another priority is establishing resilient and localized supply chain for critical raw material and equipment to reduce vulnerabilities. Increasing investment in R&D with focus on emerging technologies like AI, quantum computing and clean energy chips will maintain competitiveness and technological leadership. Furthermore, promoting public-private partnership will help scale fabrication and assembly, testing and packaging or OSAT capabilities efficiently. Government incentive should be leveraged effectively while focusing on both export opportunity and domestic market need. Lastly, fostering ecosystem wide innovation from chip design and fabrication to packaging and testing will ensure sustainable growth and global competitiveness for India's semiconductor industry.